Today we're going to talk about the end behavior of a polynomial. So let's start with the definition. What is end behavior? The end behavior is a description of what happens to y as x approaches infinity or negative infinity. So if we have some sort of graph, what we're curious about is not anything that's happening in the middle, but just what's happening at the end. What is going to happen as we zoom all the way out over here, or if we zoom all the way out over here? What's going to happen to the y-coordinate as x approaches negative infinity or positive infinity? So how would we describe the end behavior of this function? So there are a number of ways that we can describe it. One way is to use the word rise or fall. So this falls left and right. Another way is to say that it's down and left and down and right. And this is referring to the fact that if we continue this pattern, the y-coordinate gets smaller as the x-coordinate gets closer to negative infinity, and the y-coordinate also gets smaller as the x-coordinate gets to positive infinity. So we sometimes write that out with arrow notation. As x goes to infinity, then we say as x goes into infinity, f of x goes to negative infinity. And this describes the right side. X is going to infinity, to the positive side, and f of x is going to the negative infinity. Also, as x goes to negative infinity, so this is talking about the left side, f of x, we want to say f of x goes down. That's going to negative infinity. Another way of saying this is that the limit as x goes to negative infinity is negative infinity. Sorry. So the limit of f of x gets closer and closer to negative infinity when x gets closer and closer to negative infinity. And same thing, the limit as x goes to positive infinity of f of x is also going to be equal to negative infinity. The last way is to say that as x increases without bound, and bound means that it's stopping or slowing down, as there's no boundary. As x increases without bound, it keeps going closer and closer to infinity. Y decreases. And of course we want to say that it continues on to infinity without bound. And then we'd say the same thing on the left, that as x decreases without bound, y decreases without bound. So these are all, this is 1, 2, 3, 4, 5 ways of describing the end behavior. You're usually going to only see one at a time, but I want you to be familiar with the fact that all of these are talking about the same thing. So what if I don't give you a graph and I just give you an equation? So there are two things that you should look at. You should always look at the leading coefficient, so the coefficient of the term with the highest degree. If it's positive, then we say that it will rise on the right. So that positive coefficient, that leading coefficient, will be the most important term when x is really big. So if that's a positive coefficient, it'll be very large. And if it's negative, it will be falling on the right. Then once we know that, we can check whether the degree of that first coefficient is even or odd. So if it's even, then we will know that the left is the same as the right. So either they both are going up or they're both going down. Whereas if it's odd, left is not the same, is different from the right. So if it if it's, say, a negative coefficient on an odd exponent, then we'll say it falls to the right, and because the left side will be different, it will be rising on the left. So let's practice a little bit. Describe the end behavior of each of these functions. So this has largest exponent of 4, and the coefficient here is positive. So I would say that as x gets closer to infinity, then f of x gets closer to infinity because this coefficient is positive. Because that is even, I know that the pattern will be the identical on the left side. So as x goes to negative infinity, f of x will go to positive infinity. So this is the same thing as saying it'll look like something's happening in the middle, but it'll be up and to the left, up and to the right. If we have a positive term, we can say the same thing here. As x goes to infinity, f of x goes to infinity. But because this is an odd exponent, we will say the opposite as x goes to negative infinity. So we'll say it's going up and to the right, but it'll be going down and to the left. So f of x will get closer to negative infinity. Here we have a case where the coefficient is negative. So as x goes into infinity, because this term will become the most important term, it'll become closer and closer to negative infinity. So as x increases, f of x decreases because of that negative coefficient. The x cubed, because it's an odd coefficient, I know that it will be going, when we're going to negative infinity, it will be sorry, that's supposed to be a negative, negative infinity. We know that f of x will have to go in the opposite direction because of the cubed. So it will be going to infinity. So this will look like that. And this one, we could do it all out, but it has the exact same leading term. It still has that negative, and it still has x cubed. So we can just say that it's identical to number 3. I mean, not everything is identical, but the important part, the term with the highest degree is the same. So it will have the same end behavior. That's end behavior.